So in the next part of this video, we are going to use the Python. I'm on Google Colab, and just will use this Google Colab environment to use the Python code to predict to find out the K1, K2, and the K3 value from this equation. So this is basically the equation that I have introduced you in the presentation, and I don't want to revisit that equation, but what our goal is, we want this K matrix, this K1, K2, and K3. This is the unknown value. So I have used. I don't want to go deep into how this equation has been derived, but the thing is that we want to know that the K matrix, it can be determined with this equation, where G is actually a matrix that is combination of the magnitude and the R, which is the epicentral distance, and 1, that is the G matrix, and it's the combination of these three elements. So what we need to do is I have got realistic or real earthquake data of 3 different magnitudes, like 6.1, 5.6, 5.3. I have just downloaded that data from the internet, and I have converted that using the NPy array. I have converted that into a matrix that is called GMAT. So this GMAT is this G matrix. Okay, what I need to do is I need to use the NP the matrix formulation to do the transpose of it, and with the help of the transpose I can find out the GT matrix, and then I can take the inverse of this matrix. And another matrix that we have is this A matrix, which actually we need to find out this A matrix, but this A, I have got capital A matrix, and this capital A is actually the matrix that includes the PGA values, the observed PGA values. So these are all the observed PGA values, but remember that this A is not this PGA values. This A is actually the log of A. So whatever we have the PGA values, we need to take the logarithm of that value to get to the log of A, log of the PGA values. So we will start the code first by importing the NumPy library. So and import map, but we don't need to plot anything, so I think NumPy is okay. Now I've got the NumPy, and this is my G matrix. This G matrix, okay. I have already explained what that is, and that's A matrix. So we just run this to have this. So now with this in our hand, the next thing that we're going to do is we need to take the transpose of this G matrix. So we will do it like this. We can say that G transpose is actually G mat and the transpose of this matrix. And I can just say that, okay, let's print, or maybe just for your understanding, this is the transpose of the G matrix. That's why we call it G. GT, you can say, you can say that this is the G matrix transpose. Okay. Okay. This is the transpose of the G matrix. And the next thing I'm going to do is I need to take the I need to just multiply the GT with G matrix. So for that, what I'm going to do is I'm going to take GT. G is equal to NP dot GT and GMAT. Okay, so that's the transpose with the GMAT, and then we need to take the inverse. So GT G inverse and that will be equal to n pi of linear algebra dot p n inverse, and I will go with the GTG. Okay, so now you can say print, and here we can print GTG inverse. So that is our first step to find the GTG. Find the GT, then GTG, and then GTG inverse matrix. So these are the three matrices we need to determine: GT, GTG, and then GTG inverse. The next is we want to find out the A matrix. A matrix, as I explained, it is stored here as A. So all I need to do is I need to convert this A into log of A. So how are we gonna do that? We're gonna use the log function. We're gonna say that A equal np dot log 10, and then the A matrix which has the all the values of the PGA, observed PGA. So once we have all the values, the next is we want to multiply the G transpose with A. So we'll use the np dot dot function. So GT and A will be equal to np dot dot. Then I need to use the GT and A matrix, and now I got the GTA also. So I've got the GT and A because I already have the GT matrix with me. So I just need to multiply the GT with A. Now I have got all the equations. Now I can use the K, which is the np dot dot, and I just need to multiply the GTG inverse with GTA, and this will be print that K matrix is, and we just need to print K. Okay. Oh, it's got this. So the Z matrix. Okay, I've not actually printed the GT matrix. I need to print the GT here. Okay, and also I need to print the GT inverse. We have this. So this is the G matrix transpose, and then you have the GT G inverse matrix, and these are the K values for us. For us, the K1 is positive, K2 is negative, and K3 is also negative. So in the next part of this video, I will explain that how now we have the K1, K2, and the K3 coefficients. So how can we use these coefficients to predict the value of the PGA for different magnitudes of the earthquake and the epicentral distance? So we have got three earthquakes, so we will have three equations. So because the K1 is same for all the earthquakes, but because the magnitude is different, so whenever you put some magnitude of the earthquake, the slope of that equation, the slope of this equation will obviously vary. So if you have a large earthquake with the magnitude which is higher, so the magnitude's slope will be higher. So it shows that the different earthquakes will have different equations because even if the K1, K2, and K3 are similar. So I'll see you in the